In this video, we're going to be talking about adding, subtracting, multiplying, and dividing functions, and we begin with finding f plus g of x, where we're given the two functions f of x and g of x. Now I'm going to write the notation f plus g in parentheses of x, but that is not going to be a multiplication of f plus g times x, even though it looks like that. This is going to equal f of x plus g of x, and I want to emphasize we are not distributing the of x, even though it appears that that's what's happening. F of x gets replaced with x squared, g of x gets replaced with 3, and that basically is the function. And you know that to be a parabola, and that is going to match graph C down below. Notice how C is a parabola, y equals x squared, and it's been shifted 3 units up. Now, instead of finding g minus h of x, we're finding g minus h of 2. This is going to equal g of 2 minus h of 2. And again, I'm not distributing the of 2, it just appears that that is the notation. So we want to begin by substituting 2 into function g. That gives us the absolute value of 2 plus 4. And then we want to find minus h of 2, where 2 is substituted into the denominator there, and we get minus 1 over 2 minus 3. This is going to equal the absolute value of 6, which is 6, minus 1 over negative 1. That becomes 6 plus 1, and that is equal to 7. For the second part, h times g of 4. That becomes h of 4 times g of 4. H of 4 turns out to be 1 over 4 minus 3 times g of 4. That becomes the absolute value of 4 plus 4. This fraction becomes 1 over 1, so 1 times 8 is equal to 8. H over g of negative 4, that becomes h of negative 4 divided by g of negative 4. And let's take a look at that g of negative 4. That becomes the absolute value of negative 4 plus 4, and it doesn't matter what the numerator is, we're dividing by 0, so this function is going to be undefined. Okay, when it comes to finding the domain of the sum, difference, and product, it will be the same for all three. F plus g, f minus g, and f times g will all have the same domain, and it will be the intersection of their separate domains. If you're looking for the domain of the quotient, you take the previous domain I found up above, and we further restrict it so that we're not dividing by 0. Now let's take that idea and look at these functions. We have p of x minus r of x. Now let's look at p of x. That's a polynomial, it's a parabola, its domain is all real numbers. This is a diagonal line, its domain is all real numbers. So separately, their domains are all real numbers. What we want to do is find p minus r of x. This will equal p of x minus r of x. P of x is the x squared plus 3x minus the r of x, which is negative 3x. So we're going to have x squared plus 3x again, which is going to equal x squared plus 6x. Now we can just look at that polynomial and know that its domain is all real numbers. Or we could look at the original two functions, and since they both had all real numbers as their domain, this would be domain of all real numbers for the combined function. So the domain here, negative infinity to positive infinity. Now let's take a look at r divided by p of x. This will be r of x divided by p of x. R of x, as we know from up above, is negative 3x, and the denominator is going to now be x squared plus 3x. Now the denominator factors into x times x plus 3, and the numerator has an x in it also, and we can cancel those x's. So we can look at this as being negative 3 over x plus 3. Now, if we were just looking at this new function, we would say, aha, the domain here is x cannot equal negative 3. But we have to look at it before the cancellation went into effect here, and so we have to make sure that it's not equal to 0 either. Two different values here. We look at it before the cancellation. Basically, we knew R had a domain of all real numbers. We knew P had a domain of all real numbers. And we found up above, in the previous part, that the domain of their sum, difference, or product was all real numbers. But here we're dividing by P of x, and we've got two possible values of x in the denominator, which could have us dividing by 0. So for this problem, the domain will be all numbers except the negative 3 and 0. So negative infinity up to negative 3, united with the interval between the two numbers, united with the numbers to the right of 0.